Everything that WebAssembly can do revolves around the stack machine, so it is very important to understand how it works. First, WebAssembly puts variables on top of each other inside the stack machine. After that, the machine can apply instructions on the topmost variables. Then, depending on the type of instruction, it may remove between 0 to 3 variables, and at the end, it pushes the result on top of the stack. For example, if we ask WebAssembly to just add 3 plus 4, first it pushes these numbers on top of a stack. Then, by performing the add instruction, 3 and 4 is removed and the result, which is 7, is pushed back on top of the stack. Essentially, the concept of the stack is a technique to keep track of data with no need to save their addresses. So, we just need to think about the order that we put or get data from a stack to find out where is our data. Also, keep in mind the lower variable is not accessible before removing the top one. So, first we need to remove whatever is on top of it to get access to the bottom one. And one more thing is that the operations result is always pushed on top of the stack, which further it could be returned as the function's result or could be used for a new operation. For example, if we pile up 4 numbers inside the stack machine and ask the WebAssembly to calculate the total sum, it starts by adding the top 2 numbers and putting the result on top of the stack. Then again it adds this new number to the next number on the stack, and it continues this calculation until all variables consumed and only the total sum remains on a stack. At the end, WebAssembly returns this value as the return value of the function, and we will receive it in our JavaScript code. Also, you may have noticed instructions are separated from data. This is another feature of the stack machine, which instructions are without operand. Instructions don't have their data, and they can only use available data on the stack. So we need to push data on the stack before performing any operation. With this overview, now we can write the body of our add2 function. First, we tell WebAssembly get underscore local $x. It means get the first argument of our function and push it on the stack. Then by typing get underscore $y, we tell WebAssembly to do the same thing for the second argument. And finally, because the type of our variables are 32 bits, by typing i32.add, we tell the stack machine to perform a 32 bits adding operation and save the result on top of the stack. So that's it. The result is returned from stack and we don't need to return it manually.